sensor operator product. My name is Matt Nugent. I'm the VP over product management here at Overwatch Imaging.
And my name is Nico Pei. I'm a product manager.
Before we go too far into it, I thought I'd go into Overwatch Imaging in a little bit more detail. We're a US-based small business founded in 2016 and have about 30 individuals working here in Hood River. And we really got our start in the wide area, multispectral kind of sensor space. So, about 7 years ago, we started making sensors for fire mapping. From then, we continued to develop our software, for our specific sensors, and got to a point where we realized that the value of Overwatch extends beyond the hardware that we're making, that the true value is that we could bring these analytics, these capabilities that we're creating to a company to a much wider audience, and that our software had value onto other platforms as well. So that's what we've been really focused on as a company, is continuing to make our software more and more portable for those sensors that exist out there, bringing that intelligence to those sensors that are, have a certain capability today, and adding new capabilities, as we continue to grow and mature our software. I think it's important to kind of understand the landscape, that the problem that we as a company are trying to solve. The full motion video gimbal was invented in 1925, and since that time, there's been a lot of innovation in that space. But one thing has always been true, and that's this guy here in the aircraft or on the ground having to move this video gimbal around, look for objects of interest, and basically maintain manual control of this video gimbal at all times. And that's not the only thing that they're doing. There is a wide array of activities that a sensor operator is expected to perform while they're taking part in their mission. So let's look at some of those things, of the demands that are on the sensor operators. We have things like flight planning, where they're actually ahead of time trying to figure out where the pilot should go to and where to task the sensor. As mentioned, they have the actual control of the sensor itself, so having to zoom and pan around and look for objects of interest. They're having to use their mental faculties and actually looking at that imagery and interrogating it for an object of interest from their perspective. And oftentimes they're having to take all of the things that they're seeing and correlate it with third-party data sources to kind of verify its authenticity. So this is not everything, but just a small amount of activities that the sensor operator is expected to be maintaining and doing at all times during operations of their mission. We have found this video from the Air Force for incoming sensor operators, and I think it's meant to be enticing to get people to come on board, but obviously I think it paints a much starker picture of the realities that a sensor operator has to face at any given moment.
The number one thing I want my new recruit to be able to do is you gotta be able to do multiple things at once. For instance, we have an individual we're trying to follow. He's in a car because he's trying to get away, and so now your job is trying to follow that individual with your camera. Can be difficult. Now, how do you know where this guy's going? You don't. So you almost have to anticipate where they're going by utilizing other programs at your disposal that show, hey, this is what the terrain looks like, these are the road options that this individual has to choose from. Oh, and by the way, they need to know if there's any civilians in the area, if there's any other cars in the area in case you do strike them. So you gotta do a lot at the same time.
So you have multiple systems running that you're monitoring, that you're communicating with, that you're trying to optimize at any given point in time.
It's you, your pilot, you're on the radio with the troops on the ground. You could be communicating with 4, 5, 6, 7 agencies all at once.
They're in charge of the multispectral targeting system and the lasers that we also use for that. Depending on the situation, they might be in charge of developing a search plan in some cases. They're also backing up the pilot on any decisions that he makes. Then, of course, at the very end, would be employing the weapons. Once that weapon is released, our job is to terminally guide those in with our lasers spotting that actual target.
The physical demands that this job is going to place on an individual's body strictly come from sitting for long hours at a time. One has to remember that they're still a part of the military and they have to work out. And even though you're sitting for 8 hours, you still have to be a healthy individual.
Okay, so that was was, I think, a qualitative account of some of the trials and tribulations that a sensor operator is tasked with. But I also want to take a look at the quantitative problem as well. And we'll look at that both at the institutional and the personal level. So on the personal level, there's a couple things that are going on. We've already established that the sensor operator is likely multitasking a great deal. And we've actually seen studies now from the American Journal of Physiology and Behavior that taking multitasking and having a person perform a simple activity, as soon as a second activity is introduced, they get a almost 36% reduction in efficiency. And while maybe that may not surprise you, obviously introducing a second thing will come at the expense of the first. At the same time, they get almost a 50% increase in their overall error rate. Now you're not just talking about mission efficiency, you're talking about the possibility of actually missing something and making an error. That same tenet can kind of actually move into task saturation. So when we interview a lot of these sensor operators, especially in the maritime space, they've told lots of stories of kind of looking at that endless blue mass and the mental load of just having to look at that for hours at a time, searching for objects of interest, can take its toll. So we actually have found a study that backs that up and looks at monotonous tasks. And what happens at the 30-minute mark is you get a very large increase in the overall error rate, 7% at that 30-minute mark, and it continues to climb. So again, the types of tasks that we're asking these sensor operators to do and the nature of those tasks, I think, makes it a ripe environment for errors to be made and overall mission success to go down. But let's not just look at the personal level. Let's look at the institutional level as well. The AGO, or the Government Accountability Office, has actually done a white paper and a study on the sensor operator tasks and jobs and impacts that that job and our inability to maintain that role is playing a part on the American government. So we've established that we have a problem here, and now I'd like to introduce our solution. So introducing our ASO, or Automated Sensor Operator. At the base of this solution is your EOIR sensor. No modification or enhancements necessary. You can bring your sensor as is. Then we have what's called our ASO processor. That's the actual hardware that can run our software. It's hardened and has all the right technology that our software needs to run. And then at the very top here, we have our Overwatch AI software. This is the thing that's actually systematically commanding the camera and stitching user-friendly imagery and analytics together and doing all of those things in real time. So this is the ASO solution at hand. And before I hand it off to Nico, we're going to look at the three main parts of the ASO workflow, and then he'll demo those in real life. So the first thing is that systematic search. So we have a mission planning module. We have that automated gimbal control that's tasking the sensor and telling it where to look and point. And we have scan patterns that are needed that represent the mission at hand. So optimized for what we're looking for and how we're doing our ConOps. Next, we have that automated detection. So this is a powerful AI processing that runs at the edge. It's sophisticated AI, so we have a bunch of different models trained to look for different things, and it's completely modular, and we bring the right set of AI to the mission at hand. And last, it doesn't do any good to be able to do all of these things at the edge if we can't get that down into a reasonable size and get it off the aircraft and into the hands of the decision makers. So we have our intelligent reporting, which really takes that data footprint and shrinks it to just the amount that we need. It's downsized to be disseminated, and it comes with all the great metadata needed for folks to do future analysis on it as needed. And now I'm going to hand it over to Nico, who's going to show you these workflow steps with actual use cases from customers.
The first thing I'm going to show you here is probably a familiar sight if you've ever operated a video gimbal in a maritime setting. So this is myself running the camera, manually steering it around, looking for boats in a maritime setting. And while I'm not the most experienced gimbal operator, I think I ran into a lot of the same challenges that these operators face. Primarily, it's mentally taxing. The this manual search, it doesn't leave much capacity to do anything beyond steering the gimbal. User interviews have confirmed that these folks are using 80% of their executive function just to steer the camera. So it doesn't leave a lot of mental capacity for anything else. Second, it's a variable quality. So humans lose focus, energy, concentration. For this reason, operators in these maritime missions are generally switched out after an hour and a half. This leads to inefficient mission planning as you have to land the aircraft, swap people out, and it drives up the cost of this work. And finally, you get inconsistent coverage. So while I can zoom in here and I can maintain surveillance on this craft, when I do that, I lose all of my peripheral vision, and you cover the area with variable quality there. So those are some of the challenges here with manual search. Next, I'm going to show you some video from ASO running. Now, keep in mind, this will be raw video. The first thing you'll see is that it's moving fast, much faster than a human operator would move, which lets it scan an area with better coverage. Secondly, you've got automatic target interrogation. So every time it detects an object, it's going to zoom back in, take a high resolution image of it, and then zoom back out and continue its search. That way you're not losing out on this wide area search as you scan. And then finally, it's doing this in both EO and IR at the same time. So you're already doubling the number of pixels, the information that's being analyzed. A human operator is only ever able to review one of those at a time. So luckily, this view right here is not what a user has to interact with. To operate ASO, we use our user interface, which is, this is accessed through a browser window. So that means it's accessible on a wide variety of devices. You don't need any special software. All you need is a browser. Multiple users can be connected to it. So you can have a controller up in an aircraft or on the ground, and you can have somebody else viewing it at a remote location. And then finally, it's pretty low bandwidth, so all of the software is running on board the system. You're just accessing it through this portal to control it. This means 1 or 2 megabit connection is acceptable, and it's robust. If it gets a dropout or anything like that, it keeps on scanning. Let me show you what this looks like using a pre-recorded mission. What you're viewing here is our user interface through a browser window. On the top bar here, you have some controls. You've got indicators and warnings right here, number of side panels. We have a large interactive map on this user interface that's going to incorporate a base map of the whole world, and you can feed in a lot of other information, such as AIS signals. So you can have AIS from an internet source or a receiver showing you the locations of all the craft in the area around you that are broadcasting their location. First thing, usually when I plan a mission, is I'll use these scan patterns here to select a target size that I'm looking for. And this is going to control the system. It's going to control the pitch and the zoom to guarantee that you have the right detail in your imagery for detecting a target of this size. So we'll usually start by selecting a target size, and then we'll go into our detections panel, and we'll enable a detector of the type of object we're looking for. So these are all subclasses that we've trained our AI neural net to detect, and I can enable them all, or I can disable certain classes if I'm looking for something more specifically. Let me show you what this looks like for an actual mission here. This is that pre-recorded mission that we flew in a littoral setting here. So first thing you'll see is our aircraft. We've got an aircraft icon showing you on the map where you are, and we've got imagery previews on the map. So right now I'm looking at mid-wave infrared. I can switch that over to RGB or EO color. And then all of these little yellow boxes here represent detections that the system's making. So on this bottom bar here, I can see each object represented by a column with important details and multiple images representing the different detections of it. On the map, you'll see those different images flickering back and forth, showing you each time it was detected. Now, as an operator, my job is typically to review these detections and essentially clear the map. And I've got a number of hotkeys to help me with that. So using my keyboard here, I can really quickly unclutter the map with the control key. That's going to space everything out, let me review these targets as a whole there. And for any one of these targets, if I want a closer look, I can open up with the spacebar what we call super chips. And from here, it's just navigating back and forth. So I can say, if I don't care about that, dismiss, 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 dismiss. Let's say we're looking for a sailboat. We can go through the super chips just by using our keyboard here. Dismiss, dismiss, dismiss. And then we found the target. There we go. So that looks like a sailboat. I see it in a couple different angles here. Once you've found the target that you're looking for, you can use the I key to mark it important, or the S key to enter stare mode, which is going to take the camera system out of the automated search and into a persistent stare on that target, similar to how a video gimbal is traditionally used. With AIS integration, you can compare the AIS information with the detection information from ASO, which is going to either give you added confidence in the detection that you've made, or could represent more nefarious activity. If you see a mismatch there, it could represent somebody misrepresenting themselves. That is ASO for a maritime mission. I want to show you a couple other missions and examples of where this software is useful. The first one here, this was a problem that was brought to us by a customer of ours. They're one of the biggest freight transport companies in North America, and they're seeing a huge loss of revenue right now to theft. It's like the Wild West out there. And their current solution is to monitor the area in a crewed aircraft with a manually controlled video gimbal. So what we're looking at right now is some folks in a scenario here. It looks like they're setting up to rob this train, and it's a single individual in this aircraft trying to maintain surveillance. With 32,000 miles of tracks, that simply just isn't scalable. So they're looking for a solution that they can scale up to cover their whole territory. And they're looking forward to a world where we've got beyond visual line of sight UAV control, and they can have multiple systems up in the air monitoring these tracks at all times. People are stopping these trains, and they're losing thousands of dollars a minute just for being stopped, on top of all of the lost merchandise. So, this very quickly scales up to, a problem that's, many, many millions of dollars for them, and, in the billions for the industry as a whole. We brought them a solution with ASO. First thing you'll see here is that ASO controls the camera pointing. So it's going to keep that focused on the tracks. You can load in the geometry of your choice, and it's always going to steer the camera for you. Now, we've got a sophisticated algorithm running on this to detect people. It uses the mid-wave infrared, and you can see it's just made a detection there. This is not just looking for hot blobs, it's actually trained to detect people, so you're going to have better results than just looking for something hot. You can see it's made multiple detections there, and the user has engaged stare mode now, so we're no longer in the search, we're now just maintaining surveillance of that detected target. We're really excited about this technology for this mission and for a couple others. We see this having a lot of applications in border security, search and rescue, law enforcement. Here it is, same software running in a more complex scene here. So this is over a city center where you've got trees, buildings. It really would be quite a task to find all the people in this area, and ASO does it with ease. Another area that ASO can serve is in this wide area mapping and change detection. So this is a mission that these FMV gimbals have historically not been very good at. And the clip I'm showing you on the right is the typical view if you're trying to capture a wide area. So I've got the camera system zoomed out. and we're moving along, covering an area, but there's always going to be a compromise between detail and coverage. So, I can cover a wider area with it zoomed out, but at a lower resolution. On top of that, it's a moving picture, so you need to be focused on it. You only have a few seconds to notice something before it moves away. And then, to send all this video to the ground requires a costly data link, lots of bandwidth being eaten up by this video. All in all, this image interpretation is costly and expensive and not very effective. I'll show you a couple solutions here from ASO. This is a product we call Quick Mosaic. So in the video on the right, you can see it's scanning a wide area, taking multiple images side to side. So this is doing it 5 times faster, 5 times higher resolution than a human operator would achieve with their scan. It's being processed on the edge, so all of that imagery gets processed in our algorithm and stitched together into this mosaic image. And this is downsized for dissemination, so you can very easily send this to the ground, at which point, an analyst can make a decision in real time as the mission still progresses. So rather than needing to wait until the mission is over and you've offloaded the data, in this case, somebody might see, there's a stand of trees in the base map that's no longer there. That can affect the mission and you can respond in real time. ASO can also automate some of that analysis work. So we have another module on there called change detection, where ASO compares the imagery from 2 flights over the same area and highlights the areas that have changed. So what I'm showing you here, this is an area that we flew over twice, and everything marked with a green square is an area that's changed. The changes are slight. You can see it kind of highlighted there with a little red arrow pointing to it. This is really like finding a needle in a haystack. If that single tractor has moved, ASO is going to find it. With change detection, ASO can really quickly automate the sensor operator's job and the analyst's job.
So hopefully through the course of this demo, you can see that ASO is a new tool that we think is going to bring powerful change to the FMV video gimbal industry. And we just kind of base the demo around 3 key main features that we want you to take away. First, it's based on an existing system. You don't need to do anything to the video gimbals that are out there. Just simply plug ASO in and you're ready to go. Next, we've kind of talked about all the error rate increases and things that are part of the nature of day-to-day sensor operator missions. And we think this will be a powerful tool that will really increase efficiency and reduce error rates and increase overall mission success due to sensor operators having ASO by their side. And last, we do things on board that in seconds that some people will need to take hours or days to deliver in the current setting. Not to mention having to wait for the data to land, ship it, and get it to the teams to do the analysis. We're bringing outcomes, real information in seconds from the edge to people's hands to better empower their decisions. The nice thing about ASO being a software solution rather than a hardware-based solution is we are continually innovating and adding functionality to it. And that is something that just requires a new installer to be able to take advantage of. It doesn't require, building a new sensor. So we do 2-week sprints here. The goal of each sprint is to have functionality that we can show to customers by the end. And we continue to develop and refine our solutions and add new functionality throughout the year, which I think is powerful because you get more and more efficiency in your missions and more access to all the hard work that we're doing on a very rapid basis in terms of a development timeline, which I think is pretty powerful. So a couple of examples of those things that we've been really only just working on in the first part of this year was, we've been talking about AIS, that's now fully embedded, and we're doing cooler and cooler things with that AIS now that's in the system, like automatically alerting the operator when there's discrepancies between what the detection finds and what the operator finds. We've realized that video gimbals have strengths and that great zoom on the sensor, and we wanted to take advantage of that. So we created a feature called Intelligent Search this year that allows us to scan things from very, very long distances, basically be completely out of sight and be able to detect different objects at great distances. And then we've taken all of that automation that we've developed for ASO, and we have a good product standing in the fire community, and we've mixed those two things together. So really created a product for video gimbals focused on mapping fires and helping in that regard. And that's only in the first couple months of this year, and more to come.